Welcome everybody to already the 7th talk in the series Do's and Don'ts of New Town Planning, part of the Epoch 45 Planning Enzyme competition for Nusantara, the new capital of Indonesia. I'm re-recording the first 2 minutes of this presentation due to a technical glitch. That doesn't make me any less excited to introduce tonight's speaker, Ben Milbourne, who is the program manager at RMIT in Melbourne and partner at Common. But most notably for tonight, Ben has been willing to share with us his upcoming publication, Biodiverse City, which was produced together with the Y Factory in Delft. This research delves into the notion that biodiversity is a cornerstone of urban planning, and the way to achieve it is rather unusual and surprising. He will combine both the theoretical take and hopefully give us some concrete handles as to how to achieve and foster, or in this case, seed that in a newly planned city.
Climate change and biodiversity loss are the two interrelated and most pressing challenges of the Anthropocene era. Global biodiversity loss is estimated to be 100 to 1,000 times higher than the naturally occurring background extinction rate, faster than any other time in human history. Biodiversity is essential for the processes that support all life on Earth, including human life. Without a wide range of animals, plants, and microorganisms, we cannot have healthy ecosystems that we rely on for the air that we breathe and the food that we eat. Biodiversity makes ecosystems resilient to environmental change, and we need it to prevent an increase in diseases in flora and fauna. We need it for climate stabilization, for the forests that cover 1/3 of land surface and lock away carbon. We need it for the purification of water, air, and soil. Earth's biodiversity provides all things that life needs on Earth, but it only works if there's a lot of it, and it's rapidly decreasing. The biodiversity we see today is a result of 4.5 billion years of evolution, yet only 200,000 years of human habitation have caused catastrophic, lasting impacts on nature. The main drivers of biodiversity loss remain humans' use of land, which are represented in this image by superimposing 4 key drivers: agriculture, urbanization, deforestation, and desertification. When land is converted to croplands and grazing lands, wild species lose their habitat and face extinction. In 2020, cropland takes up roughly 11 million square kilometers of Earth's total habitable land of approximately 64 million square kilometers. In 2020, Tokyo was the only city with a population over 26 million people. Data from the United Nations Population Division reveals that urban populations have increased more than double in 2 decades. As population growth leads to increasing food needs, agriculture expands. Rapid expansion and unsustainable management of croplands and grazing lands is a main driver of land degradation, causing significant loss of biodiversity and associated ecosystem services. Forests are among the largest biodiversity reservoirs on Earth, yet forests are in crisis. Within 2 decades, nearly 100 million hectares of net forest area have been lost. In 2020, a significant 11.1% of which occurred in tropical forests. Land degradation resulting from agricultural expansion, population growth, causes a significant loss of biodiversity and ecosystem services. Land degradation is defined by the Food and Agricultural Organization of the United Nations as a long-term decline in the ecosystem function measured in terms of net primary production. results from overuse and overappropriation by humans. Humans have appropriated 25 to 30% of the Earth's annual land net primary production, yet we represent less than 1% of the planet's biomass. So why is this relevant to Nusantara and the Epoch 45 program? Overlays of the 6 key threats to biodiversity: agriculture, hunting, logging, pollution, invasive species, and climate change, as shown on this map, identify global locations with the greatest biodiversity risk. The bigger the circle, the higher the risk. And the second biggest circle is centered on Borneo. The construction of built environments, especially at the scale of whole cities, is inherently environmentally damaging. The establishment of a new city in an era of environmental crisis, particularly for a city located in Borneo, demands reconceptualization of who cities serve, how they are organized, and how they operate, and critically, how cities can contribute to biodiversity rather than degrade it. The question is how to do that. Early iterations of the biodiversity city research focused on biodiversity within existing cities and our relationships with the living things that surround us. The Wild and the City studio carefully studied Amsterdam's unmaintained areas for clues about the role of biodiversity in cities. Identifying that biodiversity is not evenly distributed within the city, in fact, it's concentrated in areas with a lack of human control, the spaces between properties, infrastructures, and buildings, the water and the vacant lots. Amsterdam's wild surfaces where there is a continuous and endless battle between the city and its unwanted guests. Ironically, these unwanted guests are often the original inhabitants of the underlying environment in which our cities exist, just waiting for an opportunity to reclaim the territory from us. Our often invisible co-citizens are many and varied and include mammals, birds, bugs, plants, also known as weeds, when they have the audacity to resist human control, and many types of fungi. Amsterdam has some quite specific natural characteristics, in particular the brick quay walls and brackish water, that shape how these ecological pioneers live in complex systems with other species in these uncontrolled and uncontained spaces, providing a wide variety of habitat opportunities where each place is connected to its inhabitants, allowing for the development and maintenance of a complex web of relationships. It is this complexity that reveals the hidden value of these small, unmaintained spaces. This living microsystem is a catalyst for another spontaneous, invisible society. The forgotten spaces of our cities can become positive devices where new forms of life start, where buds begin to grow and seeds begin to sprout. This raises the question, what if we stopped maintaining the whole city? Amsterdam is an active system with a wide variety of maintenance programs, including, but not limited to, a system of water locks that pump dirty canal water out into the IJsselmeer, the adjacent bay, 3 times a week. Every street is swept twice a week, and in the tourist centre twice a day. Specialized cleaning boats scoop out fallen leaves from the canals. Buildings are high pressure cleaned of debris that provides habitat for plants. And there's countless other activities that continuously maintain the surfaces and infrastructure of the city. After 6 months, leaves carried by the wind deposit in gutters, eventually clogging them and forming a humid and fertile compost. Frozen puddles melt and leave broken bricks, revealing the soil beneath. The still water of the canal starts mixing, and the whole canal becomes brackish and weeds start to grow. After 1 year, soil long trapped beneath the pavement gets exposed to the sun and the rain. Other species jump in, and soon leaf litter adds to the rising pile of debris, clogging the sewer grates. The canal starts to turn into urban wetlands. After 10 years, eventually roofing nails start rusting and their grip starts to loosen. That leads to interior leaks and progressive structural deterioration. After 50 years, bricks buried in the soil retain moisture, attracting pill bugs, which act as decomposers, feeding on rotten plants. Wolves return to the city, attracted by abundant prey. Roof trusses, held together by metal connection plates, exposed to water by the decaying roof, fail and buildings collapse. And by year 100, Amsterdam resembles a rich swamp biome with few traces of its temporary human guests. For me, the most interesting outcome of this studio is that maintenance in built environments is antithetical to biodiversity, rather. That is, by maintaining the built environment, this is a process of making the physical fabric of the city or our cities inhospitable to most other living organisms, but that the absence of maintenance makes cities inhospitable to people, revealing a fundamental and perhaps irreversible dichotomy between how existing cities operate and our desire and need for greater biodiversity. Later iterations of this research, undertaken at KU Leuven in Belgium, address this dichotomy through retrofitting the city with a new skin that provides extensive new habitat for plants and animals. This studio introduced a number of key ecological principles that have informed the ongoing development of the research, including the notion of bioclimatic regions or biomes, that is, regions of the world with similar climatic properties. According to the WWF, there are 14 terrestrial biomes, including tundra, taiga, mangroves, deserts, savannas, and a wide variety of forest types, including tropical rainforest. The research also introduced the key idea of keystone species within a biome for a selected location. While individual species often vary a lot between locations within a biome, a kangaroo in Australia versus a gazelle in Africa for savanna biomes, these species types provide similar ecological services within each biome type. And each of these keystone species have a specific habitat, energy, and nutrient requirement that needs to be met in order for them to survive and thrive. And finally, the food web, which shows the relationships between keystone species, who eats whom, how nutrients are processed, etc., and how energy is transferred from species to species through a series of trophic levels. That is super predator, predators, prey, and the lowest level, vegetation, which produces biomass. In reality, the global food web contains billions of animals, plants, and fungi. The simplified food webs used in this research are crude tools that enable rough calculations of the relative number of each species required to sustain a functioning ecology. So to test how to reshape an existing city to accommodate different food webs and ecologies, the city of Lille in northern France was selected as a site of experimentation. So to transform the city, we need to establish who we are working with, that is, our clients, and what is the program. To do this, we need to develop a food web with two super predators. That is to calculate the number of individuals of each species required to support a simplified ecology. To do this, we need to develop a food web with two super predators, 6 predators, and 12 biomass producers. Super predators eat predators and prey. Predators eat prey, and prey will eat vegetation, the producers of biomass. These calculations provide the number of individuals of each species required to make a food web auto-self-sufficient. But all of these living things require suitable habitat. A catalogue of bricos, a term developed in the context of the research, was developed that are able to be placed in different parts of the urban environment, on facades, roads, roofs, streets, urban equipment, and other parts of the built environment. These bricos can be linked, combined, multiplied, connected to one another in different ways, becoming an extensive green network. By attaching bricos to the existing surface of the city, layer by layer, we eventually develop a new skin. With the number of individuals of each species identified, we need to work out how much habitat or bricos of each type is required. The existing surface area of the city is sampled and then analyzed to determine the total biomass production capability. And then whether this new bricos skin of the city can sustain the biome-specific food web that has been selected to be examined. So what would it look like if we were to transport a fragment of old Lille to a tundra biome and transform it to sustain a functioning food web? Walls would be transformed to provide habitat for birds to nest. Roofs transformed to support grass and moss and other frost-resistant vegetation. Interior spaces are retained to support human habitation, but this transformation is not enough to support apex predators. As a whole, the food web requires those apex predators to sustain it in the longer term. The fundamental issue identified in these earlier phases of the research is that, at least in a Western or modernist tradition, we tend to conceptualize city and nature separately. In Amsterdam, the city is either for humans or for the wild. In the Lille experiments, nature occupies the skin of the city, the humans the interior. This separation is codified in language, at least in English, where we have entirely separate lexicons for related concepts in natural and urban terms related to the constructed environment. When in reality, cities are ecologies, albeit generally very biodiverse, poor ones. The current phase of the research seeks to eliminate this conceptual distinction between humans and habitat, cities and nature, and to construct a new type of biodiverse city. Building on the earlier research, we sought to gamify a user interface that allows users to manipulate a range of different factors to explore the spatial consequences of how we exist in cities that privilege all living things, not just humans. This builds on a long history of MVRDV and Y-Factory work exploring data-driven urbanism, including the Data City Metatown project from 1999 and Region Maker from 2002. As with the earlier research focused on Lille, the first step is to select a biome and its location to host the proposed city. In this case, the tropical rainforest biome that will host the new city of Nusantara. With its specific climatic, that is abiotic, and living biotic characteristics of this biome and location. Also, as with the Lille research, the first step is to develop a food web, in this case by selecting an apex predator, which identifies the number of subpredators, prey, and vegetation individuals required to sustain the web. The key question in this iteration of the research is how to integrate humans as ecological service providers within the food web, as well as consumers of ecological services of other individuals within that web. The most critical question being, how do we feed people? This is obviously both biome specific, but is also dramatically affected by how food is produced. For example, hunter-gatherer land use involves obtaining food through hunting, fishing, gathering of wild plants without any form of agriculture. If we were to supply all of the current world's population with food in this manner, we would need another 68 planets of surface area to grow this food. A food forest food production technique mimics natural ecosystems with layers of edible plants, promoting sustainable food production via agroforestry. To feed our current populations through food forest type food production, we will still need more than the dry surface of the planet. Biodynamic farming integrates organic practices, composting, crop rotation to enhance soil fertility and produces nutrient-dense food sustainably. This is 10 times more space efficient than the food forest food production technique. However, still would require 81% of the dry surface of the planet to feed the world's current population. And finally, artificial agriculture relies heavily on synthetic inputs like fertilizer, pesticides, etc. to maximize yields, resulting in very high levels of food production and human density, however, with significant negative biodiversity impacts. The next step in the biodiversity maker user interface is to determine the mix of food production land uses and explore how this affects human population and biodiversity indices. As the density of food production increases from food forest type, or the mix of food production types increases from food forest to biodynamic farming to artificial farming, human population increases and biodiversity decreases. When the land use mix meets both biodiversity and population targets, the user can continue the total number of habitat biotype units with varying abiotic properties, the number of different agricultural biotype units, and finally, the number of human habitat units required to support the human and non-human residents of your city fragment is identified. Users are then prompted to select the first unit they would like to aggregate. This unit then appears in the middle of an aggregation field with a black arrow on each side, which shows where the next unit can connect. As a second unit is selected to aggregate, the system will apply the aggregation rules of what unit is allowed to go next to what, based on minimum distances from different model types to make sure that that abiotic system connects correctly to the next one. For example, water edges of water-based modules can connect to other water-based modules, but cannot connect to deep soil modules. After the first units are aggregated, more placement options will start appearing, leaving users with more choice as to what units to place in certain locations, quickly starting to build the surface of the city. Users can then continue to aggregate manually or let the system aggregate the rest of the units to make a full model of the city precinct. Manipulating porosity levels in the larger aggregation system increases human population density while decreasing biodiversity indexes. Once an iteration is selected that has achieved the human population and biodiversity levels desired, it can be baked out and the model populated with detailed biotype modules, which is then ready to be explored through VR and other tools. The user interface can be applied to different biomes and different locations around the world, including this example in Finland, exploring the boreal forest, where different apex predators were selected and human food production focused on fungus production, leading to different densities of human population and biodiversity indices. Or the Chaparral city located in the Middle East, near Lebanon, again with different apex predators influencing different formations of the city fragment and different spatial outcomes. This research is the result of many hands across multiple years and is a work in progress with the final configuration of the city fragments still being developed. But it's worth noting that everyone involved in this project has contributed significantly over the duration of the research. And that's about it for me.
Well, Ben, that's quite a story. I made a ton of notes that I'd like to kind of feed back to you, which allows hopefully the people online to post some questions in the chat that I will then kind of try to regurgitate and also feed to you if that's okay. Time for the time that we have. So I'm really struck by the simple fact that as urban planners, we are now seemingly wholly dependent on wild animals. Your opening is extremely powerful. The idea that apex predators determine the success of natural energy production in a region. That I think even the most progressive ecologists, or rather urbanists pretending to be ecologists, would not venture that far out in their thinking. So that's a wonderful opener, and then you go to the next step, introducing man as part of that process. That's where things for me become both very intriguing and also very challenging. I think everybody agrees with the proposition that the inhabitants of that certain region we're talking about, let's say Nusantara, that those people need to be fed, and ideally with nutrients coming from the region. And then you end up with a really quite an intriguing but also puzzling conclusion, which is that the current systems don't allow for us to feed ourselves, even if we think in the most progressive terms that have become almost blunt buzzwords: the food forest, permaculture, biodynamic farming. Things that we throw around as silver bullets, and you very persuasively claim that they're actually not sufficient. So maybe we can start at that point. It has to be the mix, if I understand correctly.
Yeah, absolutely. So the key question in the later part of the research is how do we integrate humans within ecologies rather than treating humans as separate from natural systems, which we all kind of agree with in principle, but like the way that we approach urban planning and urban design continues to situate the city as separate to nature. So if we're going to be serious about integrating biodiversity into cities, we need to fundamentally rethink how and, well, more specifically, who cities are for. And all of the other non-human living things, non-human animals and plants, etc., require habitat and um, energy and kind of food consumption, etc. So I guess the question is, I mean, the question around how you feed people is really interesting. It's the hardest part of all of this. Like, do we incorporate food production into the city? And if we do we incorporate all of the food production required to feed humans within the city, within its own boundary? Um, and one of the reasons why we chose to tackle that as a core problem is that the key driver of biodiversity loss is agriculture, and occurs outside of the city. So you can either think of the city as the footprint of the physical city itself, or you can think of the footprint of the city as its productive hinterland that feeds it, which is in reality kind of what the impact of the city is. So we were starting to think of the city in those terms, as its footprint as well as its productive zone or zone of production, and treat both of them the same. Whether or not the intensity of food production should be consistent across the entire territory of the city, I think, is an open question. The way that this kind of iteration of the research is presented is it's a very small fragment of a city. It's kind of a sub precinct, and kind of it's a type that could be deployed. I think future iterations of the research would look at different types of fragments. Some that would be more dense in terms of food production, and others that would be more dense in terms of human habitation. So you'd get a variety of different types of zones within the city, or kind of precincts.
Sure, sure. Well, the beauty for us in Indonesia is that just simply looking at the Desa Kota, the
Yes.
whole notion of food production and urban systems as two separate worlds is completely outdated. So we are in that sense we are in the position that we can skip that part.
Mm,
But I think you touch on a nerve that's quite important. Like there will be specialization, there will be intensification within some sort of larger field, and then the I think the key question becomes logistics. Certainly, when fresh produce has to be moved around, there's a time limit, there's
mm.
energy involved, etc. I think that's probably what's going to spin um, this urban system that you're talking about beyond the model that you present. Because if I
Mm.
understand correctly, your gaming model is quite uniform, right?
It is at the moment. Yeah, that's correct. So it's the specialization that needs to be brought into that. So where parts of the city have different focuses. I mean, one of the things that I think we all love about cities is that different areas have different characters, um, both in terms of uh, notions of productivity. Some areas are focused on work, other areas on education, etc. But also in terms of kind of cultural qualities around where different activities occur. So that's not captured in this research yet. But I think it's when the research goes to the next scale and starts to think about the city as a network of different nodes, or areas with different characters, then it starts to take on kind of the next scale up, which it needs.
Right. That makes a lot of sense.
Mm.
That's very interesting. Maybe that allows me to squeeze in one final cheeky, maybe even rather Dutch question before I go
Mhm.
to Professor Weewick's question that I'm reading now. So in that description, the notion of city is doesn't feel right to me. It almost feels outdated. Are you guys already kind of venturing into a new definition of what city would be, or even just dropping the notion as a whole?
Well, that's a good question. No, not yet. Um, but the point around the glossary, I think, is really important. And the distinction that exists between ecological terms and urban terms. There was a piece of work that we did in the last studio that looked at mapping between those two lexicons. So the idea of territory versus precinct, um, circulation versus roaming, etc. It's kind of these terms describe very, very similar things, but because of our conceptual distinction between the built environment and the natural environment, have kind of existed separately. So there was a piece of work on developing a new um, synthesized lexicon um, that kind of eliminates that distinction. And that allows us to think about kind of more conventional design activities in different sorts of ways. So if you use a new term to start to think about circulation and movement, that is kind of a hybrid between ecological descriptors and urban descriptors, it frees you from those conventional approaches to ways about thinking about how to move through built environments. So that there's a indexicality between the terminology and the results that when we start to break it down starts to become quite interesting. So the answer to your question is perhaps yes, like it's not a city, it's something else.
Right. You're literally building or putting together the building blocks, the concepts and the language as you go.
Yes.
Yeah, that's fascinating. I have to say, also just because very often when you encounter a glossary, especially from a sort of scholarly background, they tend to be quite archaic, and I think that's what you've encountered as well. Let
Mm.
me go to Professor Wiewick's question. Allow me to give it a little bit of context. Indonesia is extremely resource rich, as you know,
Mhm.
but I don't think we acknowledge the biodiversity as a part of that resource spectrum enough. Um, so I think her question is, how do we frame it in a way that it would land on a practical level with the policymakers, or how do we frame it to give it policy hands and feet that it can be maneuvered and become implementable?
Yes. So I think it's a question of framing value, as it always is. I mean, that's kind of a key question for kind of any um, urban designer. I think the there's a number of ways of doing that. I mean, increasingly, there are policy frameworks around describing the value of biodiversity as a not only an intrinsic asset, but an explicit asset, and putting a dollar value on the retaining of biodiversity. And in this case, the proposition is to actually increase biodiversity in through regenerative approaches to urban design rather than simply approaches that minimize environmental damage. So
Right.
there's ways of putting a dollar value on that. But I also think there's there's a number of ways of talking about the qualitative impacts of increasing our kind of engagement with biodiversity in cities. So having plants and animals around us and being more focused on our role as actors within these ecologies is really important. Because it allows us to start thinking about how our activities can support the other living things that we rely on. And which is one of going back to the distinction between notions of the built environment and natural environments. One of the byproducts of that is we externalize a lot of the costs of the operation of the city. So we externalize waste, we push it out, we treat it like human waste, but also kind of physical waste from our consumption gets pushed out and put into landfills, etc. Um, and we externalize the cost of food production by having that outside the city. So when we start to think about the city as a auto self-sustaining system, it minimizes the externalization of those costs and those inputs. Um, and I think, like in a very practical sense, we can start to talk about that minimizes the cost of operating the system, both in terms of monetary energy costs, but also in terms of environmental costs.
Wow. That's very refreshing, I have to say, because traditional angle of, let's say, carbon credits, credits that you might get for reforestation, which we have done, and then you fill in the form, and the form is so rudimentary
Yeah.
that doesn't make any sense. But then it's sent to people in, I think in Washington, that rubber stamp it, and somehow it
Yeah.
works. That's shocking. But the system you describe is requires a whole new thinking, and I would imagine quite a radical change in management and policies. So there lies a big challenge. Maybe on a more stupid level, how do we take the first step of taking away the stigma that talking about biodiversity doesn't make you a tree hugger, but actually is a core, is a key to unlocking all these benefits?
Yeah, I think that as a perception has changed, is changing, as recognition of the value of environmental systems increases. Um, Not only, I mean, again, not only as an intrinsic value, but as a tacit one that leads to productivity gains in various dimensions. I grew up in Tasmania, in southern Australia in the 1990s, during a period of a lot of conflict around this as a particular issue. There was a big movement to stop native forest logging, and it was very divisive in the community. But over time, that division has decreased, and there's a genuine appreciation of the natural environment in that part of Australia, at least. And interestingly, over time, that natural asset has become one of the most significant assets for Tasmania in terms of tourism and economic development. Um, so th this shift has occurred certainly in my lifetime, and seeing how community perceptions shift over time is actually really positive, and that these things can be assets. And so the natural environment can be assets for communities rather than something that's perceived as inhibiting development. It can be something that promotes it, particularly in this framework where um, urban development is tied into operating with natural systems rather than against it. The point around maintenance for me was really interesting. Like going back through the older research, it started to identify that all of these maintenance systems that we use in built environments are about excluding the things that we don't want. Um, because our built environments are not designed to work with the natural systems within which they exist. So if we reconceptualize how the built environment works, we don't need maintenance because maintenance is resistance. If we work with those systems, we don't require the resistance.
Mm. That's interesting. We heard very similar arguments in previous talks where I wrote down here, laissez-faire was one of the terms people like Pedro and Rob Rojagama have been using to say, well, just a hands-off approach will do a lot to allow nature to take control. But in our environment, it is truly quite bleak and monofunctional as a
Mm.
plantation of hardwood. So I'm curious if nature would indeed, if it needs triggers, or if nature would indeed somehow reestablish itself, as you show in your slides.
It depends on the time frame that you're prepared to wait, I
Right.
think. So I mean, if you've got a couple of hundred years, then definitely. Like if
2045.
Okay, so not a couple of hundred years then. Um, but that's the thing. Like eventually these systems will take back over if we stop maintaining things. But it's the long time frame. So I would imagine and suggest that catalysts are needed. Um, and it's really around those keystone species and starting to reintroduce those and increasing the biomass is the big catalyst. So as soon as biomass increases, particularly vegetation, the habitat is produced for all of the prey animals, predator animals, etc.
Right.
One of the big discussions in the context of this research, which, if I'm kind of being transparent, was never really resolved, is the conflict between humans and predator animals. So, I mean, we had this kind of very long discussions around what do you do about the tigers and the lions, etc. Um, I mean, and then there's kind of other examples of that, like animals that are dangerous to humans. So how do you manage those conflicts? And to be honest, at this point in the research, it's silent. It hasn't been resolved. But the other thing to kind of note is like the built environments that we're proposing are not fully natural environments. They're constructed. Um, they're constructed and they have a version of an ecology, but it's not a full ecology because humans are in it and they're extracting energy and nutrients from those systems. So if we're incorporating food production into the city in some ways, it frees up more of the other territory of a region or the planet for those fully wild spaces to exist. So instead of having the city and this ever expanding agricultural hinterland, it's rolled into the same thing, allowing more natural systems to survive and thrive.
I love that. Is maybe technical or sort of a technically sounding question. The biomass that is needed to kickstart that process, could that come from agriculture? Because that's a far easier way to kind of artificially bring in a biomass rather than
Mm.
grow
It depends on the type of agriculture, I think. So many types of industrial agriculture are monoculture or monocultural. There was the whole thing around the land use mixer and the kind of agricultural production mixer was a way of starting to address the conflict between human density and biodiversity, and starting to think about having some areas that are highly intensive or intensively dedicated to food production, and other areas that are not, are more devoted to biodiversity maintenance, and not starting to think about the territory as a unified system, starting to kind of think about it as pockets and differentiated.
it.
So yes, but it depends on the type of agriculture and its balance with other things. One of we've in the past spoken quite a bit about the Desiccato, which I think is an incredibly fascinating urban system that does produce very high density while maintaining food production in between it. But I think that has the potential as a model for developing these types of systems where agriculture, biodiversity, and human habitat exist sympathetically um, without kind of compromising any of them, really.
Yeah, yeah. I feel also with John Doyle, your colleague at RMIT, one of the conclusions we drew early on was that that system worked beautifully for centuries until the food had to travel to the near city, let alone a faraway region, with increased pressure on the logistics, on highways, bringing in big lorries, et cetera, et cetera. So for IKN, for Nusantara, what would that mean? People actually farming their own food? That might be one bridge too far.
Yeah, I don't think, I mean, I think it's the localization of food production is the critical thing, not that everybody has to do it. I mean, I personally enjoy growing food, but it's not going to feed me entirely, given the size of my rooftop, which is not very big. Um, but I think it's the critical point is that it's a local, not global, um, or even kind of regional. It's that so when it stays local, you can start to capture the byproducts of food production. It starts to cycle those nutrients and cycle the energy within the local systems. When you're transporting food across the country or across the world, you're pulling all of those nutrients and all of that energy out of the local system, and it starts to throw it out of balance. So I don't think you don't need to be growing it yourself, but it'd be good if it's grown in the local area so that you're capturing those the energy and the nutrient cycles, or sustaining them at least.
Right. Yeah, that makes a lot of sense. Before we run out of time, allow me to go to one remark that resonates very strongly with a statement that our senior official on the project at that time, Pak Bangbang, made, who stated IKN has to become more than it is today. It has to become a forest city, even to the point that we will live amongst animals, and we really don't know how that is anymore. And that statement, he formulated it, and it was far more articulate than I was, formulated beautifully, and that really resonated and stuck with me. And now you mentioned something very similar. The role of man has to be kind of revisited of mankind in that urban, non-urban hybrid that we are sort of vaguely trying to define.
Yeah, absolutely. I mean, and I think that reconceptualization is that we start to think of ourselves as ecological service providers, not just consumers. And I mean, certainly since probably arguably since the Enlightenment, we've seen ourselves as separate from nature. The consequence of that is that we are almost exclusively ecological service consumers, rather than contributing back into those ecological systems.
That's a killer ending, Ben. Thank you so much. Yeah, it really is. That's beautiful and well-rounded, and thoroughly enjoyed that. I hope you were able to have full signal and we're online. Poviwi, do you want to do the wrap up?
Yeah. Okay. Thank you, Ben, again, and also Pak Neville. I know that you have a project, yeah, on this, and look forward for having the publications. As Pak Neville has mentioned, I really like the way you reframe the questions, Pak Neville, that how, since, this kind of issue is not really so acknowledged in our case in Indonesia. So I hope, back to our competition, IPOH, I do hope that the framing can be there in our participants who join the competition. Yeah, I would like to also update that the number of the participants keeps growing around the world. Yeah, Neville, we look forward to have more participants in the future, and invite people also to keep joining our lecture series to have a more innovative idea for the competition. And yeah, I think all the materials can be accessed through the Epoch 45 website. And please, for the participant, keep joining and have an update from the website. And yeah, look forward to meet you all again in the next lecture series. Next year, yeah, I think, Neville, do we still have the lecture series for this year? I kind of forgot our schedule.
I think one more. Let me check right now.
One more for this year. Yeah, so see you in the following week. And for Ben, thank you. I hope we can keep in touch and have a further discussion on this. and maybe seeing you offline somewhere in Indonesia or in Melbourne.
Sounds
I
great.
give
Thank
you,
you for having me.
like, Neville, if you have some additional info to be added.
No, I'm very keen to let Ben go. Thank you so much, Ben. That
Okay.
was truly insightful.
Thanks, everyone.
Yeah, it's already too late.
Good night.
Yeah. Thank you so
Yeah.
much, Ben. It's too late for you.
No problem.
Bye-bye.
Bye-bye.
Yeah.
Night,
Thank you,
guys.
everybody. Thank you, Neville. Bye-bye.